When performing electrical installations in log homes, there are some important techniques to consider. Firstly, log notches. Notches must be cut into the logs to accommodate electrical wiring or conduit. Use a chainsaw or router to create notches that are deep enough, but not so deep as to weaken the logs. Secondly, drilling holes. Drill pilot holes before driving screws or nails into logs. Use a sharp drill bit and apply pressure evenly to prevent splitting. Avoid drilling too close to the edges of logs. Thirdly, conduit and wiring. Use metal conduit to protect wiring from moisture and insects. Secure conduit with conduit clamps or straps. Pull wires through conduit carefully to avoid damaging them. Fourthly, electrical boxes. Use metal electrical boxes that are rated for outdoor use. Secure boxes to the logs with screws or toggles. Ensure that boxes are level and flush with the log surface. Fifthly, panel location. Choose a central location for the electrical panel to minimize wire runs. Mount the panel on a fire-rated wall or on the exterior of the home. Sixthly, wiring methods. Use non-metallic sheath cable or metal-clad cable for wiring. Avoid running wires perpendicular to logs to reduce the risk of damage. Seventhly, grounding. Install a grounding rod and connect it to the electrical service entrance panel. Use copper wire and ground clamps to connect the grounding rod to the electrical system. In addition to these key techniques, there are several additional tips to keep in mind. Inspect the logs, check for any cracks, rot, or damage before installing electrical components. Use weatherproof materials. All materials used should be resistant to moisture and ultraviolet rays. Plan ahead, determine the locations of outlets, switches, and fixtures before starting installation. It's always a good idea to consult with a professional if you have any doubts or require additional guidance. Contact a licensed electrician who specializes in log home installations. Consider the National Electrical Code, or NEC, requirements for residential electrical installations. The NEC provides detailed guidelines for wiring, grounding, overcurrent protection, and other aspects of electrical systems. Familiarize yourself with the relevant NEC articles and tables to ensure compliance. For example, NEC Article 210 covers branch circuits, including requirements for the number and type of circuits, conductor sizing, and overcurrent protection. NEC Article 250 covers grounding and bonding, including requirements for grounding electrode systems, equipment grounding conductors, and bonding of metal parts. NEC Article 300 covers wiring methods, including requirements for cable types, installation methods, and protection against physical damage. When sizing conductors, use NEC Table 310.15b16 to determine the allowable ampacity of conductors based on their size, insulation type, and ambient temperature. Remember to apply correction factors for ambient temperature and the number of conductors in a raceway or cable. For example, if you are using type THHN conductors in an ambient temperature of 40 degrees Celsius and there are more than 3 current-carrying conductors in a raceway, you will need to apply correction factors to reduce the allowable ampacity of the conductors. Use appropriate overcurrent protection devices, such as circuit breakers or fuses, to protect branch circuits and feeders from overloads and short circuits. The overcurrent protection device should be sized to protect the conductors it serves, in accordance with NEC Section 240.4. For example, if you are using a 12 American wire gauge copper conductor with a rating of 20 amps, you should use a 20 amp circuit breaker or fuse to protect the conductor. Install ground fault circuit interrupter, or GFCI, protection in areas where electrical outlets are likely to come into contact with water, such as bathrooms, kitchens, and outdoor locations. GFCIs are designed to detect ground faults and interrupt the circuit to prevent electric shock. NEC Section 210.8 provides detailed requirements for GFCI protection in dwelling units. Use arc fault circuit interrupter, or RFSI, protection for branch circuits that supply outlets in bedrooms, living rooms, and other areas where arc faults are likely to occur. RFSIs are designed to detect arc faults and interrupt the circuit to prevent fires. NEC Section 210.12 provides detailed requirements for side protection in dwelling units. When installing electrical boxes in log walls, use extension rings or box extenders to bring the boxes flush with the finished surface of the wall. This will ensure that the cover plates and devices are properly supported and aligned. When running cables through log walls, use grommets or bushings to protect the cables from abrasion. This will prevent damage to the insulation and reduce the risk of electrical shock. When connecting wires to devices, use wire connectors that are appropriate for the size and type of wire being used. This will ensure a secure and reliable connection. When terminating conductors at the electrical panel, use torque screwdrivers to tighten the terminals to the manufacturer's specified torque. This will ensure a proper connection and prevent loose connections that can cause overheating and electrical failures. Label all circuits and devices clearly and accurately. This will make it easier to identify and troubleshoot problems in the future. Keep a record of all electrical work performed, including wiring diagrams, panel schedules, and inspection reports. This will provide a valuable reference for future maintenance and repairs. Remember to obtain all necessary permits and inspections before starting any electrical work. This will ensure that the work is performed in accordance with local codes and regulations. When working with electricity, always follow safe work practices. To energize circuits before working on them, use insulated tools and wear appropriate personal protective equipment. Be aware of the potential hazards of working with electricity and take steps to protect yourself and others. Understand the different types of wiring methods that are permitted by the NEC. Non-metallic sheathed cable or NM cable is commonly used for residential wiring. It consists of 2 or more insulated conductors enclosed in a non-metallic sheath. Metal-clad cable, or MC cable, is similar to NM cable but has a metal sheath for added protection. Conduit is a metal or plastic tubing that is used to protect wires. The NEC specifies the types of conduit that are permitted for different applications. Understand the requirements for grounding and bonding. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current. Bonding is the process of connecting metal parts together to create a low impedance path for fault current. The NEC specifies the requirements for grounding and bonding in different types of electrical systems. Understand the requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from overloads and short circuits. The NEC specifies the requirements for overcurrent protection in different types of electrical systems. Understand the requirements for wiring devices. Wiring devices, such as switches and receptacles, are used to control and connect electrical equipment. The NEC specifies the requirements for wiring devices, including the types of devices that are permitted for different applications. Understand the requirements for lighting fixtures. Lighting fixtures are used to provide illumination. The NEC specifies the requirements for lighting fixtures, including the types of fixtures that are permitted for different applications. Understand the requirements for appliances. Appliances are electrical devices that are used to perform specific tasks. The NEC specifies the requirements for appliances, including the types of appliances that are permitted for different applications. Understand the requirements for electrical heating equipment. Electrical heating equipment is used to provide heat. The NEC specifies the requirements for electrical heating equipment, including the types of equipment that are permitted for different applications. Understand the requirements for air conditioning and refrigeration equipment. Air conditioning and refrigeration equipment is used to cool and refrigerate. The NEC specifies the requirements for air conditioning and refrigeration equipment, including the types of equipment that are permitted for different applications. Understand the requirements for swimming pools and spas. Swimming pools and spas pose unique electrical hazards. The NEC specifies the requirements for electrical installations in swimming pools and spas, including the requirements for grounding, bonding, and GFCI protection. Understand the requirements for hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. The NEC specifies the requirements for electrical installations in hazardous locations, including the types of equipment that are permitted for different applications. Stay up to date on the latest changes to the NEC. The NEC is revised every 3 years to reflect changes in technology and safety practices. It is important to stay up to date on the latest changes to the NEC to ensure that your electrical installations are safe and compliant. When planning your electrical layout, consider the future needs of the home. Install extra outlets and circuits to accommodate future electrical loads. Consider the placement of outlets and switches for convenience and accessibility. Make sure that all outlets and switches are accessible to people with disabilities. Consider the use of energy-efficient lighting and appliances. Energy-efficient lighting and appliances can save you money on your electricity bill and reduce your environmental impact. Consider the use of smart home technology. Smart home technology can automate many aspects of your home's electrical system, such as lighting, temperature control, and security. Before starting any electrical work, make sure that you have a clear understanding of the scope of the project. Obtain all necessary permits and inspections. Make sure that you have the necessary tools and equipment. Wear appropriate personal protective equipment. Follow safe work practices. De-energize circuits before working on them. Use insulated tools. Work in a well-lit area. Avoid working in wet or damp conditions. If you are not comfortable performing electrical work, hire a qualified electrician. A qualified electrician has the knowledge and experience to perform electrical work safely and correctly. When hiring an electrician, check their credentials and references. Make sure that they are licensed and insured. Get a written estimate before starting any work. Be sure to communicate your expectations clearly to the electrician. Inspect the work after it is completed to make sure that it meets your expectations. Remember that electricity can be dangerous. Always follow safe work practices when working with electricity. If you are not sure how to do something, ask for help. Your safety is your responsibility. When selecting electrical boxes, consider the size and type of wires that will be used in the box. The box should be large enough to accommodate all of the wires without overcrowding. Choose a box that is made of a durable material that will withstand the elements. When selecting conduit, consider the type of environment in which the conduit will be installed. Choose a conduit that is resistant to corrosion and physical damage. When selecting wiring devices, consider the amperage and voltage rating of the device. Choose a device that is rated for the circuit on which it will be used. When selecting lighting fixtures, consider the type of light that is desired. Choose a fixture that is energy efficient and provides adequate illumination. When selecting appliances, consider the energy efficiency of the appliance. Choose an appliance that is energy efficient and will save you money on your electricity bill. When selecting electrical heating equipment, consider the type of heat that is desired. Choose equipment that is energy efficient and will provide adequate heat. When selecting air conditioning and refrigeration equipment, consider the energy efficiency of the equipment. Choose equipment that is energy efficient and will save you money on your electricity bill. When working with electrical systems, it is important to understand the difference between voltage, current, and resistance. Voltage is the electrical potential difference between 2 points. It is measured in volts. Current is the flow of electrical charge. It is measured in amps. Resistance is the opposition to the flow of electrical charge. It is measured in ohms. Ohm's law states that voltage is equal to current times resistance, or volts equals amps times ohms. This law can be used to calculate the voltage, current, or resistance in a circuit if the other two values are known. For example, if a circuit has a voltage of 120 volts and a resistance of 10 ohms, the current in the circuit is 12 amps, or 120 volts divided by 10 ohms. It is also important to understand the difference between alternating current, or AC, and direct current, or DC. AC is the type of electrical current that is used in most homes and businesses. It is characterized by a sinusoidal waveform that changes direction periodically. DC is the type of electrical current that is used in batteries and electronic devices. It is characterized by a constant voltage and current flow in one direction. Electrical systems are typically designed to operate at a specific voltage. In the United States, most homes and businesses are supplied with 120 volts or 240 volts AC. It is important to use electrical equipment that is rated for the voltage of the electrical system. Using equipment that is not rated for the voltage of the electrical system can be dangerous and can cause damage to the equipment. Electrical systems are also protected by overcurrent protection devices such as circuit breakers and fuses. These devices are designed to interrupt the flow of electrical current if it exceeds a certain level. This helps to prevent overloads and short circuits, which can cause fires and other hazards. When working with electrical systems, it is important to follow safe work practices. Always de-energize circuits before working on them. Use insulated tools. Wear appropriate personal protective equipment. If you are not comfortable performing electrical work, hire a qualified electrician.